Hello students, today we are going with the chapter Alcohols, Phenols and Ether. It is in chapter 10 of the new book, while it is in chapter 11 of the old version of the chemistry NCERT book. So anyway, we are going with this chapter of these alcohols, phenols and ether. So let us be depicting out regarding phenols and ether particularly. I would like to say that it is actually water derivative. If you know about that water HOH, if this is the water with two lone pairs of electron, making the oxygen having the hydrogen in the bent shape of 104.5 degree. Similarly, if I take alcohols, it is just a derivative of water. I will say it as ROH. So you will see that there will be the difference of ROH, how the angle would come up, oxygen, here it will make a bend shape, similarly as that of the water, but it will be roughly around 109 degree. So this is how it differs, but it depends upon the R, whether you are taking methyl or you are taking ethyl, propyl and so on, but it will be something more than that of the water. When you take the other derivative of water, with aromatic hydrocarbon, it is called phenol, and this is what we call as alcohol. So actually it is water derivative, alcohol and phenol. Today I would like to cover three important things. First is about the classification of alcohols, number 2 about the preparation of alcohols, and number 3 the physical properties of alcohol. So student, you just tighten up yourself, take your copies and get ready for the classification of alcohols. So here we have the classification of alcohols. There is alcohols with the carbon with sp3 joined with the OH, and alcohol with the carbon joined of sp2 joined with the OH group. So when the hydroxyl part is being attached to that very carbon which is sp3 hybridized, and the hydroxyl part which is joined to that very carbon which is sp2 hybridized. In this way we are going to differentiate it. First, this is the first thing that you should keep in mind. Now alcohols that bears with the sp3 carbon atom. Here we divide into primary alcohol, secondary alcohol, tertiary alcohol, allylic alcohol and benzylic alcohol. So you know student, when there is only one alkyl group, you can take the alkyl group as CH3 or C2H5 or C3H7 and so on. So when you have one alkyl group, it is called a primary. When you have two alkyl groups, it is called as secondary, and when you have three alkyl groups, it is called as tertiary. But remember, as all the four hands of carbon are well satisfied, there is no double or triple bond, so it is sp3 hybridized carbon. And so this we put as primary alcohol, secondary alcohol and tertiary alcohol. All these are aliphatic alcohols. So similarly, if we go to this part, this is sp3 hybridized carbon. So if you focus it more, you can see CH2 is sp3 hybridized, while this very C, which is neighbor to it, is sp2 hybridized. So if in allylic alcohol, the OH group is attached to that very carbon which is sp3 hybridized, and that sp3 hybridized carbon is attached to that very carbon which is sp2 hybridized. In that very case, we call this as allylic alcohols. I can just tell you once more. Be sure that if the OH group is attached to that very carbon which is sp3 hybridized, and the sp3 hybridized carbon is attached to that very neighboring carbon which is sp2 hybridized, it is called allylic alcohol. Next to go is benzylic alcohol. This OH group is attached to a sp3 hybridized carbon. Why? Because all the hands of this carbon are well satisfied, all the four tetrahedral hands are being satisfied, and OH takes one of the bond, and this is sp3 hybridized, but it is the other carbon, the other hand is joined with a benzene ring, so we call this as benzylic alcohol. So student, you can see these are the alcohol which is having the OH attached to that very carbon, which is sp3 hybridized. And if we go for the next phase, that is alcohol which is joined with the OH group is attached with the carbon which is sp2 hybridized, we have vinylic and the phenolic group. Sometimes we call this as aryl alcohol also. So this vinylic alcohol, this carbon is sp2 hybridized. This carbon is sp2 hybridized. Why? Because one of the hands is a double bond here. So it is sp2 hybridized. Here also you can see it is a benzene ring having this double bond, alternate double bond. So it is joined with a double bond. So, and it is a benzene ring, so we call this as phenol or aryl group. So student, this is how we are going to classify alcohol, and the point you have to note it for the coming test. Today the next part is about the preparation. We are going to prepare alcohol from 5 different areas. One is from the alkenes, second from the Grignard reagent, the third from the alkyl halides, fourth from the carboxylic group, and the fifth is from the carbonyl groups. So student, let us focus now to the alkenes. The alkenes, when we are giving for acid hydrolysis. So when we are doing acid hydrolysis, remember the acid here is sulfuric acid in the presence of water at very low temperature, maybe ice cold, and at a high pressure, you are going to get the alcohols. Or you may do in this way, this ethene, if you take concentrated sulfuric acid and in the presence of concentrated sulfuric acid and ethene, what happens, it is that sulfuric acid breaks up into H plus and OSO2OH minus. This H part, H plus takes by one carbon, the other part takes by the second carbon, and it forms CH3, CH2, OSO2OH, and on steam it undergoes a cleavage to form with the help of the steam HOH. Here you can see this H will be taken by this portion, and CH3, CH2OH comes over here as ethyl alcohol, and again we are going to get here back the sulfuric acid. The third one is by the by borohydride, that is when we take an alkene, unsaturated alkene, this alkene with the borohydride, you can see getting back here CH3, CH2, CH2, BH2. One of the hydrogen of the boron, it goes to that very carbon which contains the less number of hydrogen. So here it forms CH2 and removing one hydrogen from the boron. Again, when it reacts with the same compound CH3, CH, CH2, then it replaces one hydrogen from the boron, replaces one hydrogen and get attached to. When the same thing here, the third hydrogen is being replaced. And when we allow it to pass through caustic potash or caustic alkalis or any caustic alkalis, here in the presence of hydrogen peroxide, you get back the alcohol with boric acid. So boric acid together with the ethyl of the alcohols. This is 3 different areas from where we are taking alcohols from the alkenes. When you go for the Grignard reagent, student, you can be sure that you are going to get it from any carbonyl group, whether it's an aldehyde or a ketone. So if you take aldehyde, say CH3 here and hydrogen here, and this is any kind of alkyl other than this or the similar this, and then X represents here a halogen. I can take here bromine. So when we take bromine over here, this becomes bromine. Here it comes CH3, here H, and this alkyl group is replaced over here. And when you go for the acid hydrolysis, similar effect you may get it here, CH3H, R dash and OH group, and MgOH takes place. Now when this is from the alkyl, from the aldehyde, You can have this when it is from the ketone. The similar process you can see here, the similar process, and you will be getting it from the ketone, the secondary or the tertiary alkyl group. So from the aldehyde you get secondary alcohol, and from the ketone you get tertiary alcohol. This is how we can differentiate alcohols also by the help of Grignard reagent. Number 3 is from alkyl halides. Any kind of alkyl halides reacts with aqueous KOH or NaOH or silver hydroxide in the presence of moisture. In the presence of moisture, it is going to produce alcohol, and if it is potassium hydroxide, KBr will be formed. It is silver, it is going to produce AgBr. So similar, you can see CH3, CH2OH and AgBr. I repeat, from alkyl halides is very easy, and we love to go in laboratories, we love to go with this caustic potash or with the silver hydroxide, and we are getting the advantage of getting this alcohol almost 98% purity. From the carboxylic acid in the presence of lithium aluminum hydride, with lithium aluminum hydride we can get ethyl alcohol. This is also very interesting that we get ethyl alcohol around 98% purity, but the main problem is this lithium aluminum hydride is very expensive. Is very expensive, so we try to avoid lithium aluminum hydride. And you know here, this lithium aluminum hydride, it can directly, without going to the aldehydes, the acid directly turns into alcohol. There is another more process called Bovelt-Blanc reduction process. Bovelt-Blanc reduction. What we do is, any kind of acid we first turn into ester. Once we get ester, we can use hydrogen in the presence of platinum or palladium or nickel, and we can get the alcohols to our taste, to our wants or to our desire. So in this way we can make the ester. From the ester we can undergo hydrogenation, and we can break up the ester into corresponding alcohols to our choice. And last to go is from the aldehydes and ketones. This is aldehyde and this ketone. Aldehydes reacts with the hydrogen in the presence of nickel, platinum or palladium, or we can use lithium aluminum hydride, but this we try to avoid it because it is expensive. We get alcohol directly. Similarly, in case of the acetone is a ketone. Here when we use hydrogen in the presence of this reducing agent, we are getting alcohol, but this alcohol is of secondary alcohol. Being secondary alcohol, and we get it from the ketone, and the primary alcohols we are getting it from the aldehydes. This we can also replace it with zinc and sulfuric acid, or tin and hydrochloric acid. So tin and hydrochloric acid, they produce enough amount of hydrogen. Zinc and sulfuric acid, they produce enough hydrogen to make the reduction process complete. So students, let us go as a whole. With the preparation of alcohols, first we go from the alkenes. Alkenes, by putting a temperature, low temperature and a high pressure and the hydrolysis of water, we can get alcohol. With concentrated sulfuric acid, we can get concentrated sulfuric acid followed by the steam distillation, we can get alcohol. And we can also get alcohol directly by using BH3 or B2H6, and we can make the entire thing. Process goes on with the help of hydrogen peroxide and caustic potash particularly, where we get the alcohol to our desired nature. We can also use Grignard reagent. Grignard reagent, this is RNGX, is the Grignard reagent. You can take CH3MgBr, you can take C2H5MgCl and so on. This is Grignard reagent. So with Grignard reagent, you can see that primary alcohols are not being formed, but it is going to produce either secondary or tertiary. So it is not favorable for producing 1 degree alcohol or primary alcohol. So we can make secondary and tertiary alcohol from the Grignard reagent. Now from the carboxylic acid we can directly, instead of going to the aldehyde then to acid, we can directly go to alcohols with the help of lithium aluminum hydride, but being expensive we try to overlook it. Bovell-Blanc reduction process, the acid is turned first to ester. Ester on hydrogenation in the presence of platinum we can get alcohol, two different varieties of alcohol we can get it. Last to go is from aldehyde and ketone. On aldehydes and ketone, when on hydrogenation they produce alcohol which is primary alcohol, and from the ketone we get the secondary alcohol. That's all. Now next part is about the physical properties of alcohols. Regarding the physical properties of alcohol, I would like to state regarding physical state, boiling point, solubility, density. Four important things about the physical nature or the physical properties. You have these four things to go in details. First, on the physical state, you know that the lower members are colorless, they are volatile, and they have a burning taste, and the higher ones are of waxy solid. I repeat, lower members are colorless, volatile, burning taste liquid. Sometimes you know that some of the alcohols are colored. These are because either some addition of colors has been done, or it has been coming from some extracts. So otherwise it would be a colorless and volatile and burning taste liquids. On the boiling point, this is very important to note that boiling points of alcohols are higher than the corresponding alkanes due to the presence of the hydrogen bonds and the polar nature. Alcohol by nature is slightly polar, it is slightly acidic even. And this is and also because of the presence of the hydrogen bond, you have to break the bonds, so you have to require more and more heat. So the boiling points of alcohols are higher than the corresponding alkanes. Now let me go for the next part. Boiling point increases with the increase in the molecular weight. So more and more molecular weights come into existence on this alcohol. The boiling point will increase. This is due to the increase in intermolecular attractive forces. While branch isomers have a boiling point lower than the straight chain. Branched isomers, when there is more and more branch, they have lower BP and then the straight chain. Why? Because due to the less attractive forces. So there is less attractive forces, and because of that the branched isomers, they will have lower BP than the open straight chain. If we go for the solubility, lower alcohols are water soluble, but the compounds or alcohols having 5 to 6 carbon and above would have lower solubility, and the solubility will decreases with the increase in the number of the carbon atoms in the chain. So lower alcohols are water soluble since they form hydrogen bonds with water, and solubility increases with branching. So if you have more and more branch, the solubility will increase since the surface area of the nonpolar hydrocarbon decreases and thereby facilitates in the hydrogen bonds. So with the branching, the solubility will increase since the surface area of the nonpolar hydrocarbon will decrease. And if the nonpolar hydrocarbon decreases, we will have more and more hydrogen bonds, and more the hydrogen bonds, I am telling you students, more the hydrogen bonds, more would be the solubility in water. Last to go is about the density. All the liquid alcohols are less dense than water. Usually we have the density between 0.8 gram per centimeter cube. Usually it is having a range within 0.8 to 0.9. So all liquid alcohols are less dense, so they will be floating on water. And it has also got an intoxicating property, and you know, like even methyl alcohol, if you just take 30 cc or 30 centimeter cube of methyl alcohol, you know, death is invariably going to take place. So it is also very poisonous, while ethyl alcohol is taken as a beverages. So alcohols cannot be dried over anhydrous calcium chloride. Anhydrous calcium chloride or anhydrous magnesium chloride, we cannot dry alcohol because it forms an addition compound. So we usually go for either distillation or fractional distillation of alcohol so that we get around 98 to 99% purity of this alcohol. So the physical properties of alcohol with the physical state, the boiling points, the solubility, the density, and while we go for the boiling points, remember primary alcohols have higher boiling points than the secondary and the tertiary. Why primary primary alcohols should have higher boiling points? It is because they can form more and more hydrogen bonds with respect to that of the secondary and the tertiary. Thank you so much.